Once upon a time, a girl asked a boy.
So what is it you're doing exactly in your studies? I know it's something with models and maths and so on, but can you give me an example? What can you actually model?
Basically everything. Stock movements, death and survival, dating and much more.
Dating? How would you model that?
Well, we could, for example, try to model my relationship status. Let's say, at Christmas each year, I could be single, dating, or married. This is called a state space, because it contains all the different states that I can be in when having Christmas dinner with my family.
Okay, but what's so special about that model? Where's the maths?
That's what comes next. But let's go for a walk. So there are different probabilities to go from one state to another. These probabilities are called transition probabilities. For example, when I am single in 1 year, the probability that I'm single next Christmas could be 0.5, and the probability of being dating, 0.5 as well.
And what's the probability of being married after you've been single the previous year?
Obviously, that would be 0, because probabilities can only add up to 1. And, when you define all the transition probabilities, then we have a discrete, stochastic process.
Discrete?
Not continuous. That is, in our case we only look at my relationship status on Christmas each year. And this stochastic process is called a discrete time Markov process, if the probabilities depend on the current state only, but not on previous states or how I got to that state.
But that doesn't make sense, right? When you are dating for 2 years in a row, you should be more likely to be married next Christmas.
If you think so, then we can just add another state, which we could call dating the same girl for the second Christmas in a row, or dating 2. Then, define some new transition probabilities, and you'll have a new, discrete time Markov model.
Wow, could we also do that for widowed and divorced?
Yes, of course. All you need, for a Markov chain model, is to define a state space and the transition probabilities between all states.
Okay, but what are these models actually good for?
Well, you could use our model to calculate the long-run probability of being in one of the states. Similarly, you could estimate whether stocks go bust, which queuing system in the supermarket works best, or when you should restock your inventory. And you can change the model to account for continuous time.
Well, it's getting late.
And change transition probabilities into transition rates.
I should go home.
Using a Poisson process, where inter-arrival times are exponentially distributed. Well, this doesn't seem to work out after all.